the title of this module is Statistics, or Basics of Statistics. So let's take a look at this vector of data. So I have an array of data, and there are several things that you can do with this. So first of all, you can estimate the size of this array, meaning the number of elements in this array. That is done by the command called size. So let me comment everything else and show you how MATLAB does it. So MATLAB gives you the full size of this basically matrix. MATLAB views this as a matrix. It's a 1 by 74 matrix. That means that it has one row and 74 columns. So in a simple language, it means that this array has 74 elements in it. Then you can estimate the maximum element. So the maximum element here is 776. The minimum element is 0. Okay, and notice that the elements here are given in the arbitrary order. So they're not in ascending or descending order. Those are in arbitrary order. You can obtain the range, meaning the maximum and minimum element, or difference between the maximum and minimum element. You can estimate the sum of all elements. This is done by the sum command. So the sum of all elements is 10,304. You can do the mean. I hope you remember what the mean means. So it's an average value of all the elements. So it's a summation of all elements divided by their number, the mean element. MATLAB can sort the elements. By default, it arranges them in an ascending order. So if you invoke the command called sort, MATLAB will rearrange the elements in this array in the ascending order. If you'd like to do it otherwise in the descending order, you just have to invoke this command sort, the name of the array, and then you have to put this string called descent. Okay, MATLAB will rearrange them in the descending order. Command mode gives you the most frequent element in the array. So apparently I picked 4 as the most frequent element that appears in my array. Standard deviation. MATLAB can compute standard deviation. And variance. So variance is the square of the standard deviation. MATLAB can compute that. Okay, and let's do some graphical work with this. So histogram, how to plot how does MATLAB plot histogram of the given value? First of all, what is histogram? Histogram is a plot. On x-axis, it has the values of the elements in the array, and on y-axis, it shows the frequency of the element appearance in the array. So let's say if the value of 4 appears 16 times, I'm going to have 4 on x-axis and 16 on y-axis. Now, so that in order not to do this for each element, what histogram in general does, it breaks up the range of data of the values of the elements in the array into bins. So what MATLAB does by default, it breaks up that range into 10 bins. Okay, so my range here is, so if my smallest element is 0 and my largest element is 776, so my range is 776. So what MATLAB does, it divides 776 by 10. So the length of each bin is 77.6. And then it's going to show the appearance of all elements in that bin in the array. It's going to sum up all those numbers, how many times each element appears. It's going to sum up the appearance for each element in that bin, and it's going to plot it. So this is done by the command called hist. So here I point out, so hist of x. Okay, so it bins the elements of x into 10 equally spaced containers and returns the number of elements in each container. So I already explained how it calculates the value of the bin, and the fact that MATLAB by default divides it by 10, this could be changed, and I'll explain this in the next segment. But for now, let's just plot this default histogram. Okay, so that's what I have. Remember, I told you that MATLAB divides the range by 10, so the length of each bin is 77.6, and if you zoom in, you will see that the length of each bin is indeed 77.6. Okay, so and it plots the appearance of all elements that belong to each bin on the y-axis. Okay, you can change the number of the bins. And the way to do it is to put hist, the name of the element, and then after the comma you specify the number of the bins that you would like to have. Okay, so again, since the range of my array is 776, if I divide it by 20, then the length of each bin will be 38.8. So don't expect these histograms to be similar. Because you are dividing by bins, so the plot might be slightly different. But these are two plots, one for 10 bins and one for 20 bins. Okay. You can do the distribution fit for this. So this is done by the command histfit. You specify the name of the array, and then you specify the number of the bins for which you plot this. And this is going to be a normal, by default, MATLAB uses normal distribution curve to fit the data. Oops. Okay, so on the right is our original histogram, and on the left you have the normal distribution fit that MATLAB has generated. You can also do not necessarily the default fit, which is the normal distribution, but any other distribution. MATLAB has the whole list of available distribution curves that it can plot. If you use help histfit command, it will show you all the list of the whole list of available distributions that it can do. For example, if you do the exponential, you just need to specify it like this. So in the string, you do histfit, the name of the array, the number of the bins, and then in the string you specify what kind of fit you would like to have. So here I'm going to have an exponential fit. So on the left is our default normal, or sometimes it's called Gaussian distribution, and on the right is the exponential fit. And next thing I want to show you is how to do the error bar plot. Okay, so basically you are going to have the given points, given values on x and y axis. So on x-axis, the error bar plot, what does it do? On x-axis, it gives you the number of the element in the array, 1, 2, 3, 4, 5. And on the y-axis, it's going to plot the value of that element. And then the error bar, what error bar does is that at each point it gives you the bar whose length is equal to the standard deviation. So let me show you what it looks like, and then I'll explain you how to get it. So my last plot here is the so-called error bar plot. So it looks a little messy. Maybe I can zoom in so that it looks a little bit more clear. So at each point, like I said, you have the error bar that goes up and down by the standard deviation. Now, in order to plot this, so MATLAB requests the array and the length of the error bar. For the error, since the length of my error bar has to be a standard deviation, MATLAB wants this to be specified for each element in the array. So in order to do that, I have to define the vector whose element, I have to define the vector whose size is equal to the size of x, and the value of each element of that vector has to be equal to the standard deviation. So for that, I take the vector of ones, whose size is the same as the size of vector x, and I multiply it by the standard deviation. Okay, and then I introduce this vector into my command called error bar, and that's how I get my error plot. Okay, error bar plot. And the last thing is t-test. If you remember what that is, so you invoke the command t-test, specify the range, specify the array name and the mean value for that array, and MATLAB gives you the value for the t-test. So if h is equal to 0, that indicates that the null hypothesis cannot be rejected, and h equal to 1 indicates that the null hypothesis can be rejected. So for that, refer to some of your background on statistics, but that's how you invoke the t-test. There is a command called t-test, and that should complete this module.